Okay, good morning. Welcome, everybody. Everybody's doing good? Okay, hey, thanks. So, this is the panel on silent data corruption. And the focus is mostly on on the need for engaging a broader community, both academia and industry, to solve this major challenge. Uh, does everybody know what silent data corruption is? Maybe, I will just give a very quick background. These are the most insidious kinds of errors that can happen in computing systems. There is a defect or something that's sitting inside the chip. You do your computation, you got your results, the results are erroneous, and you have no idea that the results are erroneous. That's the most scary kind of stuff that can happen to your computing, and these are called silent data corruption or silent errors. So that's the focus of today's panel. And very importantly, the focus is on manufacturing defects that are happening inside the compute chips. Not inside the DRAM or not inside storage, but inside compute chips that are doing real computation, for example, CPUs or TPUs and so on. So the question really is, how do we solve this problem collaboratively through open compute? So we have 4 distinguished panelists. We have Rama Govindaraju from Google, Zane from Intel, Sriram Sankar from Meta, and Vilas Sridharan from AMD. And I guess since the title says, academia, so I'm from academia. My name is Subhasish Mitra from Stanford. So the way we will do this, we will start with Rama giving a high-level overview, followed by, there will be Q&A. Rama, you want me to advance slides?
If you could, okay. Please. Thank you. So I'll be trying to help explain the problem statement and the scope of the problem and the challenge that we face, and why it's important for the entire community to get engaged in addressing this challenge for the computing industry. Next slide. So, my vice president, Amin, keeps asking me every 3 months, when is this problem going to be solved? And I keep telling him that the problem space is growing faster than our ability to solve it, so the problem is actually diverging. And when we see a bend in the curve and I can see a light at the end of the tunnel, I'll let him know. And it's been 3 years since we got engaged in this, and I do not see the light at the end of the tunnel. And that's very worrisome. And that's the reason for this forum, to sort of raise awareness in the entire community to figure out how we collectively solve this problem. So what I think is at stake is the trust of our users. Now imagine I told you that 1 in 1,000 planes is going to crash. None of us would get onto a plane. It's that order of challenges that we are seeing. And most modern computers have more than one of these processors, right? So the probability of failures just keeps multiplying. So this is a problem that we need to get ahead of. The scope of the problem is far bigger than any of us had imagined, right? And the other challenge we also see is the current approach is clearly not sufficient. The tendency has been that, okay, we'll do more of our current verification methods, or this testing or scan testing or what have you. But what we have seen is that is not really moving the needle, right? And we need substantially new approaches to solving this problem. The defect mechanisms are hard to diagnose and quantify accurately. So, if it were an easy problem, we would have solved this, we wouldn't need a panel. This is a hard problem, and we should recognize that it is a hard problem. It'll require the best brains in the industry and academia to figure out how we solve this problem for the future, right? And it also requires end-to-end solution. There's no clear solution in sight in the near term. So in the short term, what should we do, right? How do we make our software more resilient? All those are things that we should be proactively talking about and working towards, right? There's huge amount of community-developed software in the kernel and other libraries and what have you. How do we start working on making them more resilient to these kind of failures, right? So it requires end-to-end solutions, and it covers the hardware and software spectrum. On the hardware side, what can we do in computer architecture to make this a more reliable system? What can we do to improve our DFT methods? How do we put in better telemetry to diagnose and localize where the problems are, right? So, and cost-effective methods for DMR and TMR approaches, right? There's lots of ideas that can be sort of pursued in the hardware side. Similarly, on the software side, How can we build more resilient software? How can we sort of reason more with Byzantine failures? What are improved screening methods that we can employ? And better forensics, and this is an area which is of growing interest, is what are the signals that can give us indication that a processor might be bad or a chip might be bad, right? How do we detect more of those signals to help us identify them faster? And there's some recent advances that have been promising, but a lot more needs to be done. So the key point is end-to-end, from the hardware and software side, there is a ton of opportunity to come up with very creative solutions. And that's why we need the entire community engaged, right? And this problem is not particular to a vendor or a particular architecture. It spans all chips, all architectures, all vendors, right? Don't let anyone fool you that there's someone is better than the other or what have you. This is a huge challenge for everybody. And since it's an industry-wide problem, it needs an industry-wide approach to solving this problem, right? So we need to get everyone engaged to first recognize the scope of the problem and also seek out opportunities on how we address it holistically from an end-to-end perspective. Next slide. So what are the goals of this panel? It's really a call to action. Come up with creative ideas, get the entire community engaged, the academic community engaged, the funding agencies in the government engaged to focus on this problem. And I'm confident that if we collectively put our minds to it, this is a problem we can solve. This is the kind of grand challenge problem we should relish. It's sort of unfortunate that we are sort of detecting this so late and getting started, but we shouldn't be in the case that 5 years down the road we wish we had done something 5 years back, right? So I hope that, we'll come to the stage where this is a very attractive area for new graduate students to say, hey, this is a promising area for us to do research in. That would be a huge success, right? A few years down the road, it was very hard. I mean, even a couple of years back, graduate students would often ask, is this a problem worthy of them spending time? If that's the kind of questions you're getting, we are failing in alerting the community to the opportunities and the challenges present here, right? One thing the community can do, and this I think Intel has done a fantastic job in opening their open DC DIAX suite, making some of the machines available. We should make more of these bad machines, known bad machines, available to the community for research purposes, right? Let's convert these bad parts, known bad parts, into high-value parts for research, right? So the reason for having this discussion in open compute is let's build an open community that contributes both machines and their tests, their logs, their methods, their results, to sort of figure out how we advance the state of the art collectively, right? And we can leverage the work that others have already done to start from there to see how we make progress further, right? And be able to vet each other's results. So building this open community of, a lab where all these machines are available, all the screening methods are available, the logs are available, the tests are available, the diagnosis is available, will really help spur further creativity in addressing this problem, right? So I think this is something we should be doing more of, and that's one of the goals we have here. And then build collaborative partnerships with industry and academic community, right? I mean, the vendors can't do it on their own. These are very, very hard problems, right? So we need the entire community engaged in sharing, what is it that we are learning, where are the black boxes that we need to poke further into, and how do we engage the best skills to try and address this problem, right? And we really need to explore new approaches to STC, right? This is a really big and tough problem which is worthy of our attention here. Thank you so much.
Thank you very much. Sriram, you want to say a few words coming from Meta?
Yeah, absolutely, right. So I think, one thing I want to call out is we were at OCP last year talking about this problem as well, right? So what has changed? So like what Rama pointed out, a lot of things have happened. We have had multiple panels. We have talked to the community, academic, industry alike. But I think what we need to understand is there is opportunity also. If you're a vendor company who's doing testing, integration, if you're like part of OCP who are contributing to different designs, there's an opportunity in here where reliability is going to be the same level. When you're getting 1 in 1,000 errors, we're not just going to look at performance, power, those kind of constraints anymore as well. Reliability, things like STC, data corruptions is going to be a primary or like kind of a first order thing to look at. So it's an opportunity. And we want to see the change in the industry, right? When we are talking to vendors, when we are talking to the community, you want to see the change. Because I feel like, we can be open. We published 2 papers. We had an RFP for academia where we had a lot of universities already involved. So a lot of what we're talking about is happening. But where is that critical mass? Where is that change happening in the industry where we are more open? We have more bugs that we can just go to a bug database and report, where we have more pods that we can just make it available to the companies, where we have more companies that can test, validate, create those opportunities, part of OCP, to kind of say, hey, we add that value in here. So that is what I would like to see, have that transformation to show like, hey, from last year to now, from now to next OCP, we don't want to be at the next OCP talking about, hey, we want more people here. It's, the time to show the problem should be long gone. Time to actually work on the problem is now, right? So that's.
Thank you. So, we have AMD and Intel. So let's start with AMD, Vilas, and then Intel. What are you guys doing about all this?
Sure, Subhasish. So I'll talk about 2 things, right? The first is I'll talk a little bit about what we're doing internally, but then I want to talk about where we think the community can help, right? So internally, I mean, this is, as Rama said, right? It's a difficult problem, and it spans basically every discipline that is involved in putting a processor out to market, right? It involves architecture, it involves design, it involves manufacturing, it involves testing, it involves, DFT, every step of the way. We need to do things, and we are doing things differently in order to help address this problem, right? So internally, I would say there's a lot of work ongoing through the entire, flow of how we take a chip from concept to launch, and even post-launch, right, in making sure that we address these issues, right? Now, I want to focus a little bit on where we think the community can help, right? So from our perspective, I would say an SDC is a symptom. It's not a cause, right? And I think one of the things that we need to get to collectively is start talking about root causes, right? Once we can talk about root causes out to the community, that's where people can really start engaging and saying, okay, what is the best way to address this, right? What is the right way to avoid this in the future? What is the right way to detect this in current parts? That, right? You can start reasoning about root causes, right? And I think we really need to get to that level of discussion externally in order to really engage the community, right? Because right now what's happening is I would just say all of us are being very reactive, right? And externally with the community, I think we need to get to a place where we're proactive about this stuff, right? And we've done this before with soft errors. You know this really well. And so 20 years ago, we were in the same spot with soft errors. Now, that's just part of how we make processors, right? And it's fundamentally we are proactive about addressing this problem from that root cause, right? And we just need to get there for the other ones.
Okay, thanks. Zane from Intel.
Yeah, I think I would echo a lot of things that you said, right? I think it does span, there are opportunities at the microarchitecture level, there's opportunities in design for test, there's opportunities in test and system level test, and we've invested in all of those things. And we've been able to move the needle, but there are also there are also some other areas that are worth thinking about. One of which is metrology. When you're dealing with the statistics of some of these problems, you're dealing with you need a large number of systems to evaluate, and sometimes the symptom is extremely subtle. And so generating like a way to even know kind of where you are, like exactly how big of a challenge you have and how it breaks down into different categories and different solution steps. So understanding better how to measure is a focus for us. And then a second piece of the problem, I think, is that when you're talking about silicon defects, you have time zero defects, you have latent defects, and that's always been true. And so even if coming out of your semiconductor manufacturing environment, you had zero defects and we'd managed to solve the problem completely, you'd still have latent defects. So you have to have the ability to maintain the semiconductor over its lifetime. And so the idea that semiconductors are maintenance-free and perfect is an idea of the past. And so we've invested in capabilities and tools that will allow in-fleet servicing to continually capture any additional problem over time. And so we've released this data center diagnostic tool, which anyone can use on our products. And we're also in forthcoming chips, we'll have a capability called in-field scan, which will create more efficient ways of doing that. Efficient testing is a big part of it, right? Because the economics of taking a server offline and running some deep diagnostic test, is expensive and sometimes impractical. So you need to have something that's very lightweight that doesn't disturb a customer workload. If you're in a public cloud environment, you're responsible to your SLAs, to your customers. You need to have a way of working on that system's resiliency. And again, we're talking about the statistical tail out of, in some cases, for some of the larger providers, millions of servers. You have to have an ability to go work on that tail without disrupting operations. And so some of those kind of technologies, really, really help. But I think those are kind of the things we've been able to come up to up until now. And I think there's definitely a need for progress, well beyond, I think those are pretty linear, straightforward approaches that we've done. And I think we really need, fundamental innovation. I think Rama said it well. The innovation, there's a broad set of categories. There's, I can imagine innovations in the way we do math libraries. I can imagine innovations in the way we design the logic pipeline. So if you're a microarchitect, or I can definitely imagine in the test community, which I'm not a test expert myself, but I'm always blown away how sophisticated test can be and how much that that can be learned.
Yeah.
And then on the software side as well.
So thank you. We have 10 minutes left. So we started at 9:34, and it's a 25-minute panel. So not 5. So so we have 10 minutes left. So I would like to make a point and then go back to the panelists. So clearly, it's great that you guys are doing something, but clearly what we need are techniques with quantifiable principles, right? With solid technical foundations, not just some hacks or some brute force methods. Now, to do that, I think a lot has to happen from an open compute standpoint. How many of you know about the Murphy and Elf experiments, from the 90s and 2000s, run by Professor McCluskey at Stanford? Okay, so I think the rest of the team has to, rest of the group here has to read those papers. And I think that's the level that we have to go to be able to solve this problem. So that's why, having these, open DC diags and stuff like that, those are good starting points. But those black box approaches are not going to fly, and we are going to be back here 10 years from now talking about the same problem if that's what we do. So as an academic, here is my starting ask, right? For every chip that escaped, for example, manufacturing tests and whatnot, and got detected later in the field, I would like to see a database, of course anonymized, with no confidential information about, what chip was that, a processor or something else, under what conditions, did it pass in manufacturing test, and under what conditions it failed later on, and if there was a root cause that was done on that chip or not, and if the root cause was done, what was found? Was it a bridging fault, or was it an open, or what? Like Vilas was talking about root causes, because if we cannot go there, we will not be able to solve this problem. So that's a starting point. What do you guys think? So next year by now, we'll have that database. So let's start with Intel, and then we'll go the other way, come back to Rama.
I think through the OCP resiliency workstream, we should work on details of a proposal like that. I think the data that you have is easy to anonymize and share. It's the data that you don't have, I think, that might be what the researchers really need, that requires more work.
That's right. Good. Go ahead.
Yeah, I agree, right? I think as part of the working group, we're going to figure out what the right mechanism is. I do want to also, echo, I think, what Zane was saying, right? I would say an immediate thing that comes to mind in a proposal like that is there's a danger of overfitting, right? Of overfitting to those problems and not generalizing. But I think that's the kind of thing we just need to work out and see what makes the most sense, right? And figure out how to enable the broader community to work on.
Okay, but that was a specific ask. You guys should be talking about more stuff. So maybe Sriram and Rama, go ahead.
Yeah.
They agreed. I couldn't believe that they would agree on a panel like this.
Yeah.
But go ahead.
I was always up for that. As long as our vendors, people.
But ask for more. Ask for more. So what would you like? Go ahead.
I would like, Rama mentioned too, right? We would like to kind of share, what is happening at that level with the industry. Of course, there's a lot of proprietary kind of, things in there. So, across vendors, across us, we should do that. But the bug database, absolutely. I think we
Not bug.
defects.
Database. I just want to make sure.
I understand. The definitions matter. The SDCs, like whatever we find. I thought you said similar, but the database with all of the errors, with like repros, with like all of the conditions that cause the bug, we are ready to like kind of provide as long as vendors are okay with it, because you need an S on the panel with like saying, yeah, we will do it by next year, right? So that's me.
Okay,
But Rama.
go ahead.
Yeah, I just want to amplify a point that Zane made about latent defects. The aging challenge is a huge one with chips that we are seeing increasing evidence of that deserves more attention. And also this continuous testing as a process that we operate in and sort of wean out and study the aging effects more deeply. And also, I think the root causing is a super important point here. So for each of these defects, having a database that helps us pinpoint, localize, and root cause, and then study the patterns of where most of the issues are coming will help us prioritize where our effort should be focused on first. So that kind of data will be super useful for the entire community so that we figure out how we collectively address the whole challenge. A quick point about overfitting. I mean, I think if we have enough data points, machine learning tells us overfitting is not an issue. So we have to get more machines, we have to get more tests, and we have to get a lot more data here to eliminate some of these outlier kind of challenges here.
That's great. Go ahead, Rama, you were saying something?
No, I think it's great that everyone is in agreement. We just need to make sure we move the needle and actually get this going rather than just talking about it next year. I mean, we want to see results by next year.
Zane, you wanted to say something? Or, okay. Anyway, so we have 5 minutes left. If there is a burning question from anybody from the audience, you can ask that. Otherwise, I have an important question to ask. Go ahead, quick.
Yeah, very. Oh,
Okay.
Me or her?
Okay, very quick. You have half a minute. Yeah.
Yeah. So my name is Walter Abramson. I'm from Proteantics, and we are actually resolving the problem that you guys are talking about for the last. And I see some people smiling because they know us. My question is this: if this was a problem, you made the comparison to an airplane, right? But we don't see that. We don't see that in the news.
You have your half a minute. Okay, you have to be quick. You already made a commercial for Proteantics. Ask the question.
What is cloaking the problem? How come we don't see that in the news every day?
It is in the news. Go ahead.
Yeah, the planes obviously address it with very expensive solutions of triple modular redundancy. We can sort of figure out how we get to the similar approaches for computing as well and make it more cost effective. But that's a step that the vendors and the community have to take. So the airline industry has solved it through very expensive means. The same with the auto industry that's using all these.
Yeah, and with my little knowledge about Proteantics, I do not think you guys are really going to solve this problem the way that you're doing it today. But you had a quick question? Quick one. Half a minute.
Yep, basically, how much do we know about it? Basically, the problem right now, and what are the indicators for the latent errors? Like how it progress with what kind of parameter? Just like there's a lack of awareness here in the audience about the problem.
One of you, please take it. Yeah, and then I have the last question.
I think we know quite a lot about semiconductor defects, and I don't think there's like some new type of physical defect. I think it's just how architectures respond to defects in this statistical tail, and as these large-scale systems that are being operated with millions of servers with great telemetry and very pristine software, you're now seeing how that affects it. And so there isn't like a new kind of, as far as we know, there isn't some novel physical mechanism going on. It's just how that's interacting with architectures at a large scale.
Yeah. No,
Thank you very much.
I'll echo what Zane said, excuse me. We knew a lot about it, but to go back to what Rama said, it's cost effectiveness that's important, right? Like, I mean, speaking for you guys, you don't want to TMR your entire, fleet, right?
Yeah. While there is, I want to call out one more thing, and then the last question probably, right? So the soft errors and cosmic rays we talked about a lot. It's 1 in a million kind of thing. We talked about latency. This is 1 in 1,000. So and that has considerable latency.
Let's
Errors are not 1 in a million.
Okay. Let's get to my last question. So we see a lot of people over here, like the 4 distinguished panelists, but the companies, especially the suppliers, right, are their hardware companies. Don't we think that we need more software-oriented people, like coming to this community? And, like what's your take on that? One of you have to answer collectively for the whole panel, and then we are done.
Yeah,
Absolutely, we need soft. I think there's no immediate solution at site in the hardware side, so we do need at least a stopgap software solution, which eventually should mature into a constantly sort of prevailing solution. So the operating systems community, the compilers community, all of them, and distributed systems, all of them have a role to play in ensuring our infrastructure is reliable and can be trusted. Yeah.
So from an open compute standpoint, we need to involve some of them in these discussions.
Exactly, yeah.
Thank you very much.
Yes, thank you.